Hello and welcome. In the previous video we talked about the OSI model. In this video we'll talk about the TCPIP model, and also we will compare about the OSI model and the TCPIP. Actually, there was a historical competition between the OSI model and the TCP/IP, but the TCP/IP ended up winning the competition, being the protocol used in networking today. So let's walk through the TCP/IP model. First of all, the TCP is created by the US Department of Defense, which stands for the DOD, okay? And we have, as you can see here on the screen, we have the application layer, the transport, the internet, and network access, okay? In the application layer, we have a lot of protocols that operate in the application layer, like HTTP, HTTPS, Telnet, SSH, SMTP, which is for Send Mail Transport Control Protocol, POP3, which for receiving emails, DNS, Domain Name System, that resolves host names to IP addressing and vice versa, DHCP, Dynamic Host Control Protocol, IMAP, and more applications. In the transport layer, we have a TCP, okay, being the reliable and connection-oriented protocol. Connection-oriented means that it establishes the connection before the peers start transmitting data between them. And UDP being the unreliable and connectionless protocol. Okay, the UDP just send the data and it hope it gets there. But there are benefits of using the UDP because UDP, the packets that send using UDP are they have like less delay, like real-time application like voice and video, okay, and video, they are intolerant to delay, okay, or they are sensitive to delay, so they need to use the UDP because it's small and it just delivers the data and doesn't care about flow control, about sequencing, no acknowledgement, or any error correction. While the TCP, it uses port numbers, sequencing. Actually, both they use port numbers, but the TCP uses sequencing, acknowledgement, and error correction. Whenever there is an error in the packet, the other side that detects the error need to resend the data, okay? And we have the internet protocol that have the IP, okay, the IP protocol, which is IP addressing, IPv4 and IPv6. We have ICMP, which stands for Internet Control Management Protocol. ICMP requests used in the ping, okay, the ping and the trace route, okay, ping. Ping, it's diagnostic tool and a troubleshooting tool that check reachability of hosts, and also the trace route or traceRT in Windows, trace route, right? Yeah, trace route. So, and we have the ARP protocol, as we mentioned in the previous video. The ARP protocol is Address Resolution Protocol that translates IP addresses to MAC addresses. And in the last layer, which is network access, we have the Ethernet, which is the common type that is used today. We have token ring, which is an old technology, is not been used for many years. We have the point-to-point. We have frame relay. Point-to-point is a point to a point. For example, we have a router here and one router. This is a point-to-point. Frame relay is multi-point. you can have router here and connect it to other routers in a hub and spoke topology, and that's a multi-access topology. We have also HDLC, which is a point-to-point type of protocol, stands for High-Level Data Link Control Protocol, and ATM, which stands for the Asynchronous Transfer Mode. Okay, so let's compare the TCP/IP to the OSI model. We have the OSI model to the left hand side, and we have the TCP/IP stack. So in the TCP/IP, the application, the presentation, and the session, they are all gathered into one layer, which is the application layer. Because really doesn't matter what happened, okay, from the generation of data to the data formatting to beginning and ending this, starting and ending the session, it doesn't matter for the user, right? So they are all gathered in the application layer. The transport layer, it's still the same, the transport layer, okay, and here we have the port numbers TCP and UDP, and the network layer become the internet layer, okay. Then we have the data link and the physical, they are both, okay, gathered to one layer called the network access, okay. That's the original TCP/IP model. Actually, the updated TCP/IP model, it looks like this. Here we have the application layer. Here we have the transport. I'm going to type T for transport. We have the internet, okay, I for the internet, and here we they kind of separate those layers together, and here is the data link, and physical, okay, physical, okay, physical layer. So that's the updated TCP/IP, updated, okay, TCP/IP. You get the idea. So we talked in the previous video about the OSI model, okay, and if you want to remember, okay, for the exam or for your career, because you need to use those layers all the time as a networking administrator, you need to know what happened in each layer, and you need to memorize those layers. So there is a phrase that you can memorize to make it easier for you to memorize all those layers right here. Okay, we start from the bottom. Actually, the phrase is please. Okay, please do not. Okay. Do not throw, okay, sausage pizza away, okay, away. Please do not throw sausage pizza away. Or all people, starting from the application layer, all people, okay, all people seem to need data processing. Okay, you can memorize the OSI model by memorizing those two. Either this one, please do not throw sausage pizza away, or all people seem to need data processing. So since we compare the OSI model and the TCP/IP, so let's see let's focus on the transport layer being the important layer in the TCP/IP. As we mentioned in the TCP/IP, we use port numbers, okay? We use the source port, which is a source port randomly generated by the computer. And the destination port being one of the well-known port numbers that's starting from 0 to 1023 and called also the assigned or well-known port numbers. Okay, we have also the sequence number in the segment header, and also the acknowledgement numbers. As we mentioned earlier, the sequence numbers are numbers that allow the this host and this host to detect if there are errors, okay? And the acknowledgement number, okay? The acknowledgement numbers as well. So let's see the sequence numbers, how they work. Let's say we have host A right here and server B right here. So when this computer send a packet to the server, okay, it will send, for example, send it with sequence number 0, okay? It will arrive to the server B. The server B will send back, send me sequence number 100, for example. Means that I'm ready for sequence number 100. And it means also that he gets the sequence number 0 with an ACK of equal 1. Okay? When the computer gets the packet in the other side, it will send a sequence number 1, right? So, and the server gets the packet and sends sequence 101, send me 101, right? Let's say to demonstrate this better, I think let's use the okay, let's say sequence number 90 right here, okay, just to make you understand this process very well. So he gets the 90, this one gets the 90, this one tells the host A that I get 90, I'm ready for 100, right? So this one will send the 100, right? This one gets it and tells him, I get 100, I'm ready for 101, okay? With the ACK of 2, because the ACK, he sends ACK 1 in the first packet, then the second packet will be ACK number 2. And that's how the sequencing work. Let's say if this host right here send a packet with sequence number 90, right? But this guy or the server B in the right hand side send a sequence number of 90. Means that this packet didn't make it. So this computer knows, okay, that he needs to resend the packet with sequence number 90 again to the server, because the packet get dropped for some reason or gets corrupted on the way. And that's how the sequence numbers work. The TCP/IP or the TCP, the Transport Control Protocol, it's reliable and uses port numbers. The port numbers, as I mentioned earlier, are there are two categories actually. There is well-known port numbers that start from 0 to 1023. Okay, and there are 16 bits in the size, 16 bits in size, Okay, 16 bits in size will give us a 65,535 port number, right? And those numbers actually in reality in computers are so big. That's why we can find big numbers, not like 100 or as an example that we did before. And the port numbers in range we said from 0 to 1023 are called the well-known port numbers. And the range from 1024 to 49,151 are the registered ports, are assigned by other application or are registered, okay? So, and the port numbers that you need to memorize either for the exam or for as being a network administrator in the future or an engineer, you need to know that the FTP or file transfer protocol uses port 20, okay, for data. File transfer protocol FTP server uses 21. Secure shell uses port number 22, telnet 23. Simple mail transport control protocol SMTP uses 25. Okay. Domain name system uses both the UDP being connectionless and the TCP the connection oriented protocol and uses port 53. Dynamic host configuration protocol or DHCP that allocates IP addresses to hosts on the network uses the UDP and both ports 70, 67 and 68. Trivial file transfer protocol, the TFTP that we're going to use so much, you know, copying files to the routers and switches and copying files from the router to the computer to save configuration and stuff like that, uses UDP and port number 69. We have the HTTP, which well-known protocol that uses TCP reliably for web browsing and uses port 80. Post Office 3 protocol, which for receiving emails uses TCP and 110 as the port number. Simple Network Management Protocol SNMP, okay, uses UDP and 161. The SNMP actually is good for managing devices. You can centralize management many devices and check, you know, hardware resources on them and stuff by using the SNMP. Okay. Hypertext Transfer Protocol Secure HTTPS uses 443 and uses, of course, the reliable protocol TCP. So the TCP or the transport control protocol uses what's called flow control, okay, the flow of data. So here we will see a concept called windowing. Okay, let's say we have the host A and host B here. Okay, so host A send the packet with, let's say, sequence of 1, S1, right? And another packet with S2, and the third packet with S3, right? So the server gets these two packets, but he didn't get the third packet, okay? So the server will say, I'm ready for 3, automatically, when this host gets, the acknowledgement window size of 2, okay, and with a sequence number of 3 means that he did get the packet number 3. This one will automatically resend the packet number 3 because he knew that the packet number 3 gets corrupted, and he will send packet number 4. So as you can see here, the host A tries to send 3 packets at a time, which is the window size of 3. But when the server gets just 2 packets, which is window size of 2, then he realized that the server can't get more packets than 2, then starts sending just 2 packets at the time. Okay, he tries to send the 3rd packet, but it gets corrupted. Then the server on the right hand side send a sequence number with "I'm ready for 5," means that he didn't get the 5. At this point, this computer really know that the server can't get more than 2 packets at a time, or the window size of 2. Okay, window size of 2. Okay, and that's called, this process right here called windowing, or TCP windowing. So the host and the server on the other side, they kind of agreed upon the window size. Okay, first of all, he starts sending like 3 at a time. Then he realized that this computer can't get all the 3. Then he realized, or he noticed, that he need to minimize the window size to 2. Okay, and that's what happened in windowing, or sliding windowing. I want to show you something. When you start like copying files, from one location to another, let's say I want to copy this, right, to, let's say, to desktop. I copy this to desktop. It was so fast. Let's say we're going to copy all this stuff to recycle bin, for example. Okay, let's do delete. Here we go. Okay, actually I need a bigger, I need more data. I want to show you that when you start copying files from one location to another, sometimes in the window, pop up, and if you check the detail, you will see that if we will go with this size, okay, we will finish copying those files in 3 hours. Then Windows realized, no. If I'm going to copy with this size, I'm going to do it in 1 hour. Then after a couple of seconds, you will see that it will take like 20 minutes. Then it's just 5 minutes. And that's what happened in the window. In the Windows, always, try to send the maximum data before the other side gets overwhelmed. And that's what's happening. That's what happened when you are copying files from one location to another, and that's called sliding window. So I hope this has been informative for you, and I would like to thank you for viewing.